Alright, here's some notes that I'm going to highlight from 7.2 and 7.3, and then also some review problems before you take the quiz today. Alright, so in 7.2 we're looking at similar polygons and shapes. Two figures that have the same shape but are not necessarily the same size are similar. Okay, hopefully that's pretty evident and obvious. Okay, how do you know if two polygons are similar? Two criteria here. Corresponding angles are congruent and corresponding sides are proportional. Okay, all the corresponding angles are congruent and all of the corresponding sides are proportional, meaning they have the same ratio. So when we congruent is an equal sign with that little tilde above it. For similar, it's just that curvy tilde sign. Okay. You'll see that in a little bit more. Okay. A similarity ratio is the ratio of corresponding linear measurements of two similar figures, right? So here in this example 1, all of the corresponding angles are congruent, right? One thing, well, obviously this is XYWZ is more vertically oriented, and KLMN is horizontally oriented, and so you got to make sure that you match up the correct sides, right? Like XY does not correspond to KL, right? XY actually corresponds to KN or LN, right? And so that's 4 out of 4, okay? And then this ratio, XW to KL, 9/6, those are not equal. So the sides are not proportional, okay? So therefore these are not similar. Example 2, these are similar triangles, right? You have all proportional sides, okay? They all have a ratio of 3:4, and then all of the corresponding angles are congruent, so therefore these triangles are similar, okay? 3 ways to show that triangles are similar, okay? I'm going to go kind of out of order actually. Side, side, side means all 3 pairs of sides are the same ratio. Okay, not congruent, because obviously one's going to be smaller and the other one's going to be bigger. And so you have side, side, side. You have side, angle, side, where remember the angle is included. It's in between two sides, and again, the sides are not congruent, but they are proportional, but the angles are congruent. And then the angle-angle postulate is if you have 2 corresponding angles that are congruent. Okay? Yeah. So in these examples here, determine whether they are similar. Okay, so in example 1, you have angle A is congruent to angle R, that's given to you. We know that vertical angles are congruent, and so these are similar by angle-angle. Okay. Number 2, again, you got to be careful, right? 8 does not correspond to 12. Okay. Well, actually, no, they did. Okay. Oh, I see what they did. Yeah, never mind. Okay, so these have the same proportion, right, or same ratios. Okay, 6/9 and 8/12. That's 2:3. Okay, and then you have these vertical angles here, and so therefore it is similar. And then for 3, these triangles are similar by side, 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 meaning all 3 pairs of sides have the same ratio. And just a quick proof here. Okay, prove that these 2 triangles are similar. You know, we're incorporating parallel lines here from a few lessons ago. Okay, OC is parallel to AR, and OW is parallel to RD, right? And so look at statement number 2, OCW, so angle C right here, right? The acute angle is congruent to RAO because the line CD is the transversal that cuts through the parallel lines OC and AR. right? And so therefore, if parallel lines, then these are corresponding angles, so they're going to be congruent. Okay. And we're going to use the same logic here for OWC and RDA. Those are also congruent by corresponding angles. Okay. And so we have two pairs of angles that are congruent, and so therefore these two triangles are similar by angle-angle. Okay. Here, the main thing that I wanted to point out is the importance of splitting it into two smaller triangles, right? Because the common mistake that some students do is, you see how here, right, the small triangle this side is 10, and the overall triangle is 10 plus x, right? So many times I see some students do this, 10 over x. That's not right, okay? The whole side for the larger triangle is 10 plus x. So whenever you see problems like these, I think it's helpful to, redraw it into two separate triangles, okay? And then you have your setup here, all right? Just a quick word problem here. Remember, I think in yesterday's notes, we want to try to convert to the smaller unit, right? And so inches is smaller than feet, and so we're going to convert 2.5 feet to 30 inches and then compare that way. And for this one, I mainly wanted to focus on number, well, I guess both, but for 5, right? And these ratio problems, so here, the ratio of the width to the length of a rectangle is 2 to 3. So we don't know what the actual ratios are, or I'm sorry, the measurements, but we know the ratio is 2 to 3, right? But since we don't know, right, we're going to have x be kind of the baseline here. And so, for area of a rectangle, it's length times width, or base times height, right? We probably should have changed this to length times width here. But 2x times 3x, okay? Using your algebra solving skills, all right? Got to take the square root at the end here, okay? So again, I wanted to emphasize how to do these ratio problems, okay? And then look at number 7. Okay, there it is. This pops up again, right? You have the small triangle AYB that's inside the overall triangle of HYV, right? And so the whole length HY is x, and then this whole length down here between y and v, that's 38. Okay, so again, it might help to draw two separate triangles here. All right. And another proof here, okay, RS is parallel to XY, right? You have angle 1 and 3 are congruent because these are corresponding angles, because QX is the transversal, right? And then 4 and 2 are congruent as well because they're also corresponding angles, all right? And so since you have, in statements 2 and 3, you have two pairs of angles that are congruent, then these triangles are similar by angle-angle. And it looks like that's it. Okay. Again, if you have questions, please shoot me an email. We do have an optional office hour Google Meet at 10 a.m. I believe, and so I'll wait around for a little bit.